Hi, Calgary. Let me know on Slack if you can hear me / see the video feed. They don't always respond? No way. Oh, Matt responded. He says 1 moment. Okay, good. There used to be a company called Perch that it was like an app, and we had an iPad, and we had this like two-way window into Calgary. So we just put the iPad here, and they could walk up to the iPad on the other end to talk to us, and we could walk up and talk to them. It was such a neat app. Unfortunately, they shut down the company. We couldn't do it anymore, but it was kind of cool because it created more of a connection. I'm guessing it's not really a big use case for many people. Oh, Matt can't see it. Ooh. Okay, let's see what we can do about that. As it says here, it's streaming. It's coming like virtual logo here. Okay, stop recording. Oh, he doesn't see the link for it, he says. Oh. I'm gonna go ask for help.
Cool.
Okay, great. Awesome. And Matt, can you please confirm that you can hear me as well? Can you guys hear me? I don't want to get started and then have to repeat. It's the most annoying thing. All right, well, I'll just get started, and we can do this, figure it out. All right, cool. Hey guys. Small group today. It's really cool. I really, really like smaller groups because we get to interact. First, I'm going to introduce myself a little bit. My name is Monica. I used to be an instructor at Lighthouse Labs. I've been a developer for 10 years. I studied computer science at U of T, and then went on to work for a number of different companies. I've worked for an agency in Toronto, a startup in San Francisco, contracting. If you'd be interested in becoming a contractor, I'm happy to talk about what that's like. It's a bit of a different kind of setup, but the beauty of that is you get a lot of freedom. Right now, I work for a company called Animiki, this company right here. And Animiki is an indigenous digital studio based out of Victoria. We're an indigenous-run company, and we work on projects, small and large, from projects for small First Nations across Canada to one of our flagship products, which is a learning management system that the government is using to teach people in government around the country about the history of Indigenous people in Canada. That project is called Sanyas. So that's me. I'm back here for a guest lecture. Really excited to be back. Spent 2 years teaching at Lighthouse, and it was some of the best 2 years I've ever had, because I really enjoy meeting like awesome people like you who are taking on such a huge challenge, and you guys are already there, so congratulations for making it through this program. Cool, so what I wanted to talk to you guys today is this technology called GraphQL. It's a fairly new technology. There's a lot of hype around it, and what it's basically for is if you are working on a React app or a React Native app or an iOS app or an Android app, those apps, I'll be referring to them as clients. They're clients because they all need to get data from a server. Data like users, a list of users to display, or like if you're building a Twitter client, you might get a list of tweets. You might need to get the current user, right? So all that data needs to come from somewhere, and typically that's done with a certain kind of API, a REST API. You guys covered REST, I think, in the course in week 7, maybe 6, 7, when we talked about Rails. Actually, no, before that even, yeah. So GraphQL is an alternative to REST. Cool. So let's see. I couldn't help myself. Okay, so just a little bit of background on why it is that we're talking about GraphQL. Do you guys know what the term API means? Like, if you had to explain it. Yeah, in your own words, what does API mean?
I was going to say I was going to answer that.
Has it come up during the course?
Yes, nobody wants to give the wrong answer.
Oh, no, just try. Just be like the thing that does things.
Well,
How applications talk to each other? Yeah, definitely.
It's just the way I understand it, it's like a convention that's set by someone who wrote a program in order to streamline gathering certain data. For example, if you're trying to get map data,
Yeah.
it says, okay, this is how you get our map data. Use our interface to program your app.
Yeah. I'll repeat this for Calgary. So one of the answers was it's a convention for how to get data. For example, if you have a map and you have a map API, it's a convention for how to retrieve map data. Yeah, definitely. And API stands for Application Programming Interface. Any other ideas related to APIs? Like,
It's kind of like we have an interface for like a GUI app, right? But it's just for software. Like this is what's available to you to use.
yeah, that's a cool connection. It's like a GUI, but for software that your program actually talks to, not like users clicking. Yeah, it's an interface. So the thing that really confused me about the word API is that it means, well, it stands for Application Programming Interface. But in practice, we have two things that are named API, and they're actually kind of different from each other. When people say the word API, they might be referring to web APIs, which are like the Google Maps API, right? Like the Twitter API. When people say that, what they mean is usually a web-based data provider for a service. So like we make JSON data requests to the Google Maps API and to the Twitter API, and we just get back data from those services. So that's one meaning of the word API. And the other meaning of the word API, which doesn't come up as often, but it does come up, and it's quite confusing when you're reading a blog post and you read API, and you're like, that's not a data endpoint. So the other meaning of the word API is a convention for how, it's almost like a library, a code library that has a number of functions you can call to interact with a program. So an example for that would be the OpenGL API. When someone's talking about the OpenGL is a series of drivers for writing rich graphical interfaces on a computer. So you could write OpenGL games, for example. And when someone talks about the OpenGL API, they're referring to the code that allows you to interact with the OpenGL library. So it's not about data over the web. It's more like calling methods. OK, so I just wanted to get that out of the way. By the way, if you guys have any questions, just jump in. It's awesome, because we're a smaller group. Don't worry, just shout it out. So like a bit of history. The web APIs that we use today and that are so commonplace, they're a relatively new thing, because it was around 2010 that the client-side application madness started. It all started, I think, with Gmail. At least this is from my own perception as a user of the web. I don't know if you guys are old enough to remember, but Gmail, at some point in time, around before 2010 actually, you hit the compose button, and instead of them taking you to a completely new page where you could write your full message, they were popping up a window. Yeah, remember that? Like you just got the window pop up. And I remember as a web developer thinking, whoa, how'd they do that? Like, you could do things like that with jQuery. You could pop open modals and modify the page while it's still loaded without having to do a full page refresh. But that was kind of new and cool. And then all of a sudden, everybody wanted to write rich client applications like that are not just like simple pages that you load to go from one page to another. And that's when we got one of the first client-side framework technologies called Backbone.js. Maybe it's come up in web searches. It's not that popular anymore, but there was Backbone. Angular came out a bit after that, and then React and Ember came out. Actually, Ember was one of the older ones. But React has been very successful today, and it's just so incredibly popular as a client-side app. Anyway, the reason I bring all of this up is because all of these applications, like React, Angular, Ember, they all need an API, a web API to talk to in order to give you a useful application. So as soon as the client-side app revolution was driven by the need for better user interfaces, and then we also needed better ways to get data from servers. So what did we use? Well, the major API, web API technology at the time was REST. REST is not, it's not a library, it's just a way of organizing your API endpoints. Yeah, REST API. So let's just do a quick review of REST. In REST, what we have is one API endpoint for every resource. So what I mean by endpoint is if you want to get data about artists, like if you want to get a list of artists, the REST convention says you go to /artists on the API endpoint. If you wanted to get all the releases for a certain artist, you can structure that like this, artist / a particular artist's ID in here, like 12 or something, and then /releases. And so on. So you can have all these different API endpoints. But let's think about this for a second. Like if let's go over a few examples. What if instead of just getting all artists that a website has in its database, what if I just wanted to get like the top artists for the homepage? How do you do that in REST? Maybe let me add to that because it might help clarify the question. So we want a REST endpoint that can give us all the artists for the homepage, top 10 artists. But then we also want to provide a search feature where I can go into that website, search for an artist's name, and get back all the artists that match that fragment I just typed in.
Okay.
How would you do those two use cases? Yes.
So for the search one, you would just go artists / search and then your query?
You could do artist / search and then the query. It would totally work. In terms of REST convention, though, I don't think they're too stoked about putting other keywords in the URL. So the /search part wouldn't quite match what REST is about.
Oh, okay.
But you could do it as a parameter. You could just do /artists
Yeah.
search equals your keyword. Awesome. How about top artists? Artist / top artists. Yeah, you know, and that's exactly how most people probably implement it, because another interesting thing about REST is nobody really follows the real REST convention. Like, I don't fully understand it, and I've been writing REST API endpoints for a bunch of years. You could do it that way, yeah. If you wanted to be a little bit more on the purist side, again, like as soon as you add a different keyword in there, it doesn't seem to follow the REST convention, but you could do top artists equals true or something. So because of that, so you just keep modifying this endpoint, and now this endpoint serves two purposes. It does searches for you, or it retrieves the top artists. And if you think about an app, you might have all these different queries that you want to run against artists. You might want to retrieve artists for several different purposes in your app. So it's kind of clumsy to have to like shoehorn it all into one endpoint. That's not comfortable. That's one of the things that is not great about REST, but it's not a big deal. One of the biggest problems, though, about REST is, let's say I'm working on an application that has a web client and an iOS client. And let's look at a particular application just as an example. Podacy. So this application, Podacy, it's actually written by one of the instructors here at Lighthouse Labs, Danny. He is an iOS instructor, so he built this app where it's a podcast discovery app. If you guys are listening to podcasts, you can go here, and I just click clicked on Give Me a Random Podcast. You can search through podcasts. You can look at users who follow a particular podcast. So what I wanted to show you guys is he's got an iOS app, an Android app, and this web app for his project. And here we're looking at a list of podcasts that came up. And technically, it's kind of hard to see this, but if you look at the URL, it says /search/ and there's a keyword here. So technically, we're looking at the search page for podcasts. If we just look at the screenshots for the Android app, see where he's displaying podcasts here for a particular user? We just get the cards, the images for every single podcast. And in this list here, we don't just get the image for every single podcast. We get, the title, link, and so on, description. Like, it's a completely different view for podcasts.
Okay.
So my point is, he would have had to write 2 different API endpoints for this, or one API endpoint that contains all the data, and then he gets all this redundant data. So what he actually did is he ended up using GraphQL as a backend, and that made things a lot easier because he could just configure exactly what data he needs to get back from the server. So that is huge, because I can't count the number of times I've worked at companies where we have an Android developer and an iOS developer, and I get a change request, a ticket to say, hey, can you please add the description to the podcast endpoint, please, to the API? And I'm busy doing other things, and then 2 days later I add the description for them. It's a blocker, right? Like, they're being blocked because I need to make a change for them. Whereas with GraphQL, we'll see that in a second, they can just, I would still have to make a change, but it's a very quick change, and chances are I would have added all those fields anyway and just left it up to them to request what data they need. So it's a lot less back and forth, and maintaining those API endpoints no longer needs to be a headache. Okay. So let's look at a little bit of architecture. With REST, what you're doing is just a diagram that shows that you have your client here. It can be a browser, it can be an iPhone app. They make requests. These yellow things are different API endpoints. And in this diagram, they're being a bit fancy. They're showing that you can get data from a database or several databases. Your data comes from a variety of data sources. We can just ignore this part here, really. But the most important thing are the yellow lines. Like, your client makes requests to different API endpoints. Whereas with GraphQL, you just have a single API endpoint. Your client describes what data it wants back from the server, sends the request. GraphQL figures out how to get that data and just sends it back. So if I want to get the current user and the top 10 artists and the top 10 releases this year, I don't need to do 3 requests, like in the 3 yellow lines. I do a single request, tell GraphQL I want all these things, and GraphQL can return them. Okay, so enough blabbing. Let's look at some actual code. I want to do a couple of things. I want to just show you guys how GraphQL works. We'll look at an existing implementation and just run some queries so you can see what the queries look like. And then we can go back and talk a little bit about how these queries actually work. And then we'll go and maybe extend this implementation and add more features to it. All right, demo time. Is the font size okay? Cool. And server, okay. So the GraphQL server implementation I have is running on Node.js. So I'm just going to start it with NodeMon Do you guys know NodeMon?
Yeah, we've used it before.
Yeah, it's just neat because you make code changes and it automatically reloads the server for you. You don't need to restart every time. Okay, so it's saying just go to localhost 3000 GraphQL to run queries. This is the coolest thing. All right, so we get this window. And I'm going to show you the backend, the database that this GraphQL API is connecting to. I basically managed to find a copy of the Discogs database from 2017. Do you guys know what Discogs is? Yeah, they sell vinyl. It's like kind of like a marketplace for vinyl records. A bit overpriced?
It's something I'm always after. It's crazy price on it.
Nice.
$80 for like a
Yeah, sometimes and then you got the crate diggers. Some of my friends in Toronto are really into that, going through the old record stores. Okay, cool. So I just extracted a subset of the data. Their database is obviously more complicated than this, but I extracted the data that they had published, which was artists, genres, these images, cover images for the records. We have labels, which is just the record label that published the record. And the kind of key piece of data are the releases. And releases is what they call an actual record, like this. Okay, so here's our GraphQL API endpoint that is giving us access to this data. So the first really neat thing about this GraphQL interface is it allows you to explore what queries you can run. This may not seem like a big deal, but I think it is, because when you've worked, for example, with the Google Maps API, remember all that documentation you had to read about how to make a request, and you need to add these headers, and you need to put exactly this search parameter. Well, with GraphQL, it just shows you. It's like a menu. Here's, what do you want? Top releases, search releases, get genres. These are all the endpoints I implemented. You could have a lot more. Okay, so let's look at top releases, for example. I just start typing top releases here. Whoops, just need curly braces. All right, so what I'm going to do on the left-hand side here is I'm going to write a GraphQL query. This is almost like writing SQL, but not really. It's a different query language. So on the left-hand side, I'm going to describe what data I want back from GraphQL, and GraphQL is just going to go and get that data for me. So I want top releases. And for top releases, you can supply a limit. So I just want the top 10 top releases. Okay, and it's telling me that I'm going to get back a release here. So I can click on release, and I can see what are all the things that I can read about a release. Okay, just give me the ID and give me the title. So when I hit play here, it's going to run the query, and boom. These are actual records from the database. Let's make this query a little bit more interesting. So I could keep adding these fields here, like the status and released. And if I hit play again, we get more data here about every single record. I can also nest some of the queries. So one of the attributes I can use for a release are images. And if you remember what the database looked like, images are actually in a separate table. So I can retrieve data from several tables at once without, needing to use different endpoints. By the way, that's true of a REST API. You can totally return nested data in a REST endpoint as well. But it's just neat that here I have the option to get the images if I want to, and if I don't, I just don't need to get them. Okay, so I'm going to type images here. And this schema tells me that I also have a choice to filter for only primary images. The way the data is structured right now, every single release has several images. If I want, I can only get back the primaries. So I'm going to go ahead and do that. I'll say, only give me the primary images. OK, and now for the images, I can click here to see what kind of data I can get back for every image. It turns out it has an ID, URI, and role. I really only care about the URI, so I'll just get that. Cool, so now I get top releases, and for every single top release, I get the images with the picture for that release. So if we just go check it out, there we go. Now, this is so cool. Man, like when you're building imagine I could be building a React app right now, and I could be saying, oh, I want to display this data. I just configure my query, and I get just the data I need in just the format I want it to be, without having to read a lot of documentation about, what endpoints do I need to hit to get images? If I go to API/releases, am I going to get images or no? Do I have to put in like some kind of parameter flag? This self-discovery feature that GraphQL has here, this GraphQL, what we're looking at right now, it's just a tool that you use in development. You wouldn't use this in production. It's just an exploration tool to see how, to get the data. And that's pretty much it. We could look at other queries, like we could do a search to search through all of the releases, not just the top rated releases. So let's see. So for search releases, I can give it a query string and a limit. I'll just give it a query of what records should we search for? You guys have any? 70s psychedelic rock. So like, maybe some like Led Zeppelin or something?
Something might be trippier than that.
Maybe trippier than that.
But let's start with that.
Sure. Let's see if we get some Zeppelin. I only have about 20,000 records in the database. And it's possible that, let's see if we can find it. Title, can we do an artist here? No, I didn't add the artist. Okay. Cool, let's run this. Query, search. I wonder if it had an error. Let me check the server log. Connects, where title. Oh, no, I guess it just didn't find anything with the keyword Zeppelin. We could try, Black Sabbath. Cool. Sabbath. Nope. Those records would be so expensive, though.
I would expect them to be in the database, though.
Pink Floyd. Yeah, I only have 20. I only have like Doobie and Floyd. Yeah, so there we go. For some reason, there's a lot of stuff from Sweden, so Stockholm comes up a lot. In Stockholm, we dwell. Okay, so that's kind of like a quick demo of what GraphQL is about, and then we can get into the details of how it actually works behind the scenes. But do you guys have any questions so far?
So
GraphQL, you would use it in development,
Or,
actually.
sorry, yeah, development. Then, yeah, I'm just waiting to see how the more details then.
Yeah.
Because this is just at first I thought it was a web app that you made, used, but it says localhost there, so is it something that you downloaded? Or
Uh,
something that you developed yourself?
yeah, so I'll just repeat the question for Calgary. The question was, where did this come from, this interface? And the answer for that is, it comes with, this was coded by someone, and it's being run by the Node application. This interface was coded by the Apollo project, which is the name of the open source repository that like basically creates an implementation of GraphQL. GraphQL is just an idea, like, and then Apollo is the actual implementation that I'm using for this demo. And they also created this nice GUI for us that does the service discovery stuff. Yeah, so who knows, maybe you would have this running in production as well. One of the old ideas of HTTP, way back in the day when researchers came out with the HTTP protocol, was that you could have like a discovery feature where services could discover what kind of queries are available. Like, this idea is really old, actually. It's just never been implemented properly. This is the first good implementation of this. And the evidence I'll submit for that is the HTTP head tag. No, not HTML, the HTTP. Head request. Yeah. So I think this was used as a way to do service discovery on HTTP servers. You were supposed to be able to, issue a head request. You know how we do GET request, POST requests? A head request was supposed to give you back a list of all the endpoints you can hit and services and so on. But it never really picked up because developers didn't want to do the extra work if nobody was going to use it. But yeah, okay. So that's GraphQL. Maybe we should take a quick break now. It's 9:46. Let's take a break. And when we get back, we can look at how this was implemented. And yeah, we can actually build. I have a little React front end that I built that's not working. And we'll build it out using the GraphQL backend. Hey. let's get to the fun part. All right. Oh, my email is up. Cool. So, okay, so we just saw a little demo of how to use GraphQL, the tool that comes with GraphQL that helps you explore the service to figure out how to make queries and get certain kinds of data from the backend. Now, what I want to show you next are two things. One is how to build that GraphQL endpoint from almost scratch. You'll see we have just one simple server.js file, and we'll build out from there. And the second part of the demo is we will go back to a version of the GraphQL endpoint that has all those endpoints like actually implemented. And I have a little React app that's waiting for data from the GraphQL server. We'll see how do you actually connect a React application to GraphQL to get data and display some info. Okay. So before we jump in, I wanted to show you guys another slide just to get a high-level view of what the GraphQL components look like. Okay, so this is a diagram of the GraphQL architecture. The queries that are coming from the client, end up in this kind of query receiver module. And then they get sent out to what are called resolvers. And resolvers are really important because resolvers are functions that allow us to actually fetch data from the database. The resolver gets information like, where is our UI? Oh. The resolver gets information like this, like the query was Stockholm. And the job of the resolver is to actually write a SQL query or MongoDB query or wherever your data is to give back the releases with the keyword Stockholm. So it's a key part of the system. Where is that? Here. Nope. Okay, so those resolver functions will then go off to your models. GraphQL models are a definition of what data goes together. So in the example we saw earlier in the demo, I had releases. And for releases, you could get things like title, ID, description. So that definition of what belongs to a release is part of the model. And then the connectors, this doesn't come with GraphQL. It's actually up to you to pick whatever database connection you're going to use. So you could use connects, like the NPM package, or you could use PG, or you can use whatever you want. That's the point here, which is kind of nice. It gives you a lot of power. And then, of course, the other level is the database itself. In our case, we're just using a Postgres database. Here, they're demoing the fact that they're just showing that you can use more than one database if you'd like to. Cool. So let's see that. You can check out master. So the master branch I have here should have a very early version of this demo with almost nothing installed. Okay, so all I have in this project right now is a package.json file that requires a bunch of packages. Apollo Server Express is the NPM package I had to install to get that GraphQL GUI and a lot of the libraries we're going to use. Body parser cores Express, these are not specific to GraphQL. These are just some Express packages we need. GraphQL tools, also part of the GraphQL. These are part of the packages you need to install. Connects is going to be the database ORM I'm going to use. And I've installed PG because I think it's required by Connects. Okay, so let's open up the server.js file. Okay, this stuff should be pretty standard. We're loading up Express, loading up body parser, loading up cores. Do you guys remember what cores is about? Cores is a package we're going to need because the React app is going to run on localhost 8080, and the GraphQL server is going to run on localhost 3000. And because those are different hosts, if I didn't have the cores set up, and if I tried to make any request whatsoever, this has nothing to do with GraphQL, but any HTTP request you make will be denied by the browser, because the browser will say, oh, you're trying to access a different server, that's not okay, unless that server says it's okay. And by installing cores, I'm basically, configuring the server to say it's all right to receive a request from localhost 8080. Okay, GraphQL Express, GraphQL Express, this is just part of the configuration we need to set up GraphQL. I'll send you guys links in the notes for how to set this up, but basically I just grabbed the quick start code that they give you on the GraphQL website. Okay, then this part I had to add, it wasn't in the sample code they give you. I'm just setting up a connection to the Postgres database and using this client. Okay, so let's see what they give us here. We have the schema that we're going to need to configure in GraphQL. And the schema/models, this is just a definition of what data we're going to want from the server and how it's organized. Then we're going to have the resolvers, which are those functions that actually fetch the data and actually return the records when a query comes in. And that's it. Like, schema, resolvers, that's all we're going to need to implement. The stuff below is just more configuration. It's kind of boilerplate that you just need to get the GraphQL server to start up. We're starting an Express application, and we're defining 2 endpoints. There's that GraphQL endpoint we were using earlier that has the GUI. But the actual GraphQL data endpoint we're going to use is different. It's just /GraphQL. We're getting it to start up and listen on port 3000, and that's it. No magic. Let's try this out. Let's actually run this. I'm running it with debug connects query, this parameter set, because this will show us all the SQL statements that are being run, and it's a nice way to kind of debug to see if the resolvers we're going to write are actually working. Okay, and first thing we get is an error. Type not found. Okay, so I know this is coming from the schema, because the schema we have is like just a boilerplate schema that's not really working. So let's fix that. In GraphQL, we need type query. Query is a reserved keyword in GraphQL because that's just the top level kind of query holder of all your queries ever. So we're going to leave that like that. But instead of my query, we're going to need to set this up to be an actual query we want. So let's do the top releases query. So I'll call this top releases. If this query takes any parameters, we can define them here in the round brackets. Notice how this looks a lot like the query I just wrote. It's just I'm kind of defining what the return type is going to be. Okay, so top releases should have a limit parameter that is an integer, because I want to be able to say limit 10 to only get the 10 top releases, or limit 20 to get the 20 top releases. And this part here, after the colon, GraphQL is asking me to say, pick a model that's going to be returned by this query. And in my case, I want the release. I'm going to return an array of releases. That's why the square brackets are there. Okay, so now that we painted this picture, we need to define what release is. And I actually already have it defined here, type release. Right now I said a release only has IDs, but let's add title as well. The exclamation marks after the data type, you might be wondering what they are. They're just saying that a title has to be returned. It's not an optional field. Okay, so let's see. We're still getting an error. Query, my query defined in resolvers, but not in schema. So what it's complaining about right now is if we look at the resolvers, I have a resolver for a query called my query, but my schema no longer has a query called my query. It has a query called top releases. So now that we've defined the structure of what needs to happen here, I'm just going to full screen this. Let's define how top releases should be retrieved from the database. Okay, so top releases is going to be a function, the resolver function, that takes 3 parameters. Root is when you're doing nested queries, like if I were to get releases and for releases get a bunch of images, the resolver for those images will have a release as the root record. Anyway, no need to get into it too much. The second parameter are the params that are being passed into the query. So this is going to be the limit. It's going to show up as a parameter. And the context is an object that I can use to set a context for every single request. One common thing to do in the context is, for example, to set a current user if the user is logged in. Because all of these different resolvers will need to know who the current user is to figure out, like, is this person allowed to see this data at all? So all that logic will go in here in the resolver. Okay, and now all we need to do is just write a query to get these top releases. Any questions so far? No? How about this async? What does this mean? Have you guys seen that before?
Not by itself at the beginning like that, but I understand.
Okay, this is a new feature of JavaScript called async await, and it's a new way to work with promises. Since you guys haven't seen it, I just wasn't sure if it was added to the course. It's a very new feature of JavaScript. Maybe let's leave it out. Let's not make it asynchronous. We'll use promises instead. There we go. That looks more reasonable. Okay, so top releases is a function. I'm just going to use the client record. Sorry, the client DB connection I have here. So client refers to the database. Here, actually, maybe let's rename it to DB. So from the database, get the releases. And I think I can just say limit and pass in the limit value that's going to be coming in through the query. Now, just in case someone doesn't set a limit, I do have 20,000 releases in the database. I wouldn't want to accidentally return them all. So I'm going to say, if a limit wasn't passed in, just do a default of 10. Okay, and this code I just wrote here, that's all connects, which you guys used, right, for one of the assignments earlier. You guys know more connects than I do, so any help is appreciated. Okay, so we're going to grab this. Then hopefully, if this worked, the promise will return the release data. And if it didn't work, we're going to get an error, in which case we should just print that out. But if we did get some data, we should return it. Okay. Okay, so GraphQL is ready to run a query, and now we can, if we reload this page here, in our list of queries, we see top releases that we just defined right now. Okay, and let's do a query, see what happens. It might not work, but that's okay, we can debug it. Okay, so top releases give me 5. And here, we only really have ID and title. See, it shows us, because those are the only 2 fields we defined in the schema. Like this part here. So we're only allowed to grab ID and title right now. Okay, and when you get this, it means something went wrong. So we can look at the error log. I suspect this is a timing issue. Let's console log this. So I'm going to run the query again. And let's see. Oh, we do get back some releases. They're an array. That should be good. But they're just not being returned. Null is returned. Yeah, and I suspect that's because we're returning from inside a promise. I wonder if we can just return the promise itself. And if GraphQL will just handle that. Yay! Worked, cool. So, do you guys want to talk about why it wasn't working before? That's promises. Man, so confusing. Okay, so console logs to the rescue. Okay, so this is before the query. This is when we see the, actually, let's rename it. So this is query done, got results. And this is returning from top releases. So when we get to returning from top releases, the function finished executing and it's just automatically returning undefined. Okay, so if we do this. Okay, so we get before the query. While we're running the query, it already returned. And then when the query is done, well, too late. Like, the results had already been sent back. The reason for that is because this code here is asynchronous. This line of code doesn't block execution. So by returning the promise, the function that is calling the resolver, that won't always work, returning a promise. But if the function that is calling the resolver knows how to work with promises, it will detect that it got back a promise and not just some set data. And run, like wait for the promise to finish executing, grab the return value that came back from the promise, feed that in.
So how would you refactor that with async await?
Oh yeah, you guys want to see the async await? So async await is a beauty. because it will actually stop execution, and the code doesn't look so funky. All right, let's do this. So the thing about async is you need to add this async label to any function that uses async await. Just a rule. Then what you can do is you just say await, and you run a function that will return a promise. In this case, just this call. And you can assign that to a variable. So I can do this. I can say await, as in wait for this code here that returns a promise to actually finish executing the promise. And this is almost like your .then. And assign the results to this variable. Then do whatever, return results. To handle errors, you always have to handle errors. If there was an error while running the query, let's just console log there. So let's run this again. Boom, it works. Isn't this a bit cleaner, right? Like, it's kind of like, this is more like how Ruby works, where you can stop execution, wait for something to return, then do something with the result. It's just easier for our puny human minds to work with. Cool, I'll leave this around as an example. Okay, so we have this resolver. What do you guys want to see next? Should we expand on this resolver a little bit, make it more complex? Yeah.
So can we just recreate what we did before?
Recreate what we did? Yeah, sure. We could recreate the whole thing.
Or it would be good to have a reference of how we use this tool and then how it's actually translated into our projects.
Yeah. We don't have a lot of time left, but I'll just quickly add. I'll add a couple more models in here so we can see how you work with multiple models in GraphQL and multiple queries. So let's implement that search. Actually, first let's return more values here. So you can string. I think a release has notes. Let's see, releases. It has status, title, released. Oh, the date it was released, data quality. Let's add all those things. Released is a string. Data quality. So let's just see that in action. Now that I've added, I need to refresh this page before it will reload what the schema actually looks like. But now if I go into a release, it shows me all these new fields I added in the schema. And because I added them, I can now make that part of my query. Now another thing I can do here is add a nested resource. So for type image, let's pull data from another table. So we have the releases table, and then we have the images table. Let's modify this so that we can say images in here and get an array of all the images for a particular release. So ID. What does an image have? An image has a role and a URI. Let's add those here. Role, string. So now that I defined what an image is made up of, I can go back in the release and I can say a release has images. And what do you guys think is going to go to the right of this? What do I type in now to reflect that a release has a bunch of images that are going to be returned?
So you said it was nested, right? It was a nested property, so could be an object, could be an array of objects.
Yeah, it's going to be an array of objects. So I'm not just going to say image here, because that would only be valid if I was returning one image. So for an array, I would do square bracket image to indicate that I'm going to return an array of image, which is what I've defined over here. Okay, so now that we've defined how this should all look, now we need to write the resolver for it. Because, actually, I won't write the resolver first, just to show you guys the error you're going to get. So if I reload this now, I go to query, go to release. It tells me I'm allowed to get images. But let's see, if I try to get the images, they're null. And the reason they're null is because I don't actually have, I didn't write the SQL query for getting images. The only SQL query I have in there is for getting releases. So what I'm going to need to do is in the resolvers, as part of, I'm going to need to add a new key here for releases. Or I think it's just release. Yeah, I think it's just release. We'll find out in a sec if it's wrong. So for release images, we're going to write another root params. We don't have any params for that. Context. So we're going to do the exact same thing we did here. So I'll just console log get images for root title. Okay, so if I wired it up correctly, when we request the images, for every single resource that's requested, this function will be called, and we should see get images for release title. Yeah, so there we go. This function is now being called for every single resource that was returned over here. And that's just done, it's wired up automatically by GraphQL. So the neat thing, that's where that root comes in, right? Because that's what I was trying to say earlier about the nested resource. Because images goes inside of a release, because it's a child of release, we need to get the actual release in order to know how to fetch images for that release. Otherwise, we couldn't do it. So I'm actually going to go ahead and rename this from root to just release, because it's going to be a release object. And now we can just do try return await db. So go to images and only get the images where release ID is release.id. And if it errors out, just print the error. Okay, so let's see what happens now. Cool, now we're actually getting some images. The ID is not very interesting, so let's look at the URI for the images. Cool, so now for every single release, whoa, lots of images for them. Every release has its own images field. This is normal. They do have a lot of images for every single release, so it's not a bug. And we can double check that because here we can also see that the queries are searching for the right release ID. I don't know why this is undefined. It's a bug in Connects, I think. It's not printing out the parameters that go into queries. But yeah, it's all good. Cool, so now we see how you get a nested resource. By the way, I could return anything in these resolvers. So let's say here that I have, okay, let's add another attribute to releases called funky, like is it funky or not? And that's going to be a bool. I can make up my own resolver for release, which, yeah, like it's just going to be a function. And I can just return true. They're all funky. Like it doesn't matter where the data is coming from. Let's get the funky field. Oh, failed to fetch. Let's see. And oh, bool is not found. Yeah, it's Boolean. Boolean. So there you go. Funky is just true. I'll take out the images because they take up a lot of space. Any questions about setting up the GraphQL stuff?
Do you mind just minimizing that code you edited out or deleting it? Because I want to see
how the whole thing looks?
Yeah.
Yeah. Maybe I can zoom out a little bit, like. And let's get rid of this guy. Is that helpful?
Sorry, what was the exclamation mark again? It was to check.
Exclamation mark says the field has to be there, is mandatory, yeah.
We're going from Ruby, and we just start using them. It's like it prints out with the error or something like that. So I was like, wait.
Oh, yeah. So going over this here, we defined the query we wanted. We defined what the models look like. This is almost like your schema file in Ruby on Rails, right, where you define what the pieces are. But the big difference here is that you can define like virtual attributes, like this funky attribute that wasn't really in the database. Like, oh, yeah, that's a really important point. My schema in GraphQL doesn't have to be connected to tables in the database. That's the big difference between the Rails schema and this. I can make up whatever data organization I want, which is kind of neat. And so after defining the structure, we just define these resolvers for the query itself, which is this guy over here. And we defined resolvers for the fields inside the release that weren't just part of the database table, like that weren't retrieved by this query here. Oh, and this is the release. Yeah. Cool. So you guys, is anyone building a React app for their project?
Yeah.
Yeah, or yeah.
Yeah.
Everybody?
Yeah.
Crazy.
Yeah.
Wow, that's awesome. Yeah, you guys could use GraphQL. It's honestly less work to set up than REST. Cool. So let's move on to the next section, which is let's actually use this endpoint in React. Okay, so I have another React app here somewhere. Okay, so I like to organize my apps by components. So this app is just a very, very simple app. It has a navbar at the top. That's just nothing, really, just a bunch of HTML. And then it has this top releases component that right now is just waiting for this top releases data to show up on the Redux store. And if top releases is not there, it's going to show the loading, this kind of loading spinner. And when the data shows up, we'll actually be able to code something in here and display the data. So nothing too fancy. Let's actually see it in action. So it should be running at localhost 8080 or something. I'll just restart the server. 8081, okay. Okay, so here it is. It's just that top releases loading spinner is showing up. Now let's take a look. I have the Redux log set up so we can see what actions are being dispatched. Right now, as soon as this component is loaded, on component did mount, we're calling the action get top releases, which is triggering this Redux action, and that's where we're gonna that kind of initiates the request for data. I am using Redux Saga. It's a tool that I use with Redux to handle asynchronous requests, actions that come in. And so the place we're going to handle that action is actually in the root Saga. Okay, so I realized this wasn't really covered in the course so far, but it's really not that complicated. I'm defining actions that are being listened for all the time. And I'm saying anytime the get top releases request action comes in, run the get top releases function. So just to test that out to see that it actually works. It works. If I reload the page, we see it works. The request is being sent. I mean, will be sent as soon as we write some code there. I'm going to delete the search releases function because we really don't need it. Just declutter this page a little bit. But what we do need to do here is write a request to GraphQL to get the top releases. So we're basically going to do the exact same, we're going to issue this exact same query that we're running here, but just from the React application. Okay, so let's take a quick look at the docs. The Apollo website has some really good getting started stuff. Just a word of warning, if you are going to use Apollo, they recommend that they have these React integrations. I really never quite liked using that. Like, you get these components, like they're coupling how you get your data with your component rendering. I haven't had a lot of time to think about it, but right off the bat, that just really doesn't make sense to me. You're supposed to do your data fetching where you handle your actions. So what I've done instead is I'm just using their kind of default simple implementation of running a query, which they describe here in create a client. The rest of this stuff is like more geared towards some custom React component. Anyway, my point with all of this is even if you weren't using React, you could use this code in anything else, in Angular, with jQuery, like it doesn't matter where you call it from. So let's go ahead and add this. So I installed this GraphQL tag npm package beforehand. This GQL function, all it does is it just parses, it massages this GraphQL query before it's sent to the server. I honestly have no idea what it does, but it just works. So, okay, and then in the actual getTopReleases function, client, oh, we need to set up the client as well. So I'll copy this. Okay, set up the GraphQL client. Okay, in our case, instead of going to this endpoint they have here, we're going to go to localhost 3000/GraphQL, which is, I'm just looking at the server code right now, which is just this endpoint we set up on the server side. Okay, and so now we're going to use this other query to run the GraphQL query. Client.query, just going to copy it. Okay, so client.query is going to issue the HTTP request, and instead of running this query they have here, let's run, just going to copy paste this query we wrote in the GraphQL Explorer. Okay, ID, title, data, quality. Okay, so assuming that this query works and we get back some data, we should just see it on the console. Anytime you work with promises, though, I really think it's a good idea to add a catch, because otherwise if there's an error, actually nowadays you do get warnings in the console, but it's possible that some of these errors get swallowed up unless you explicitly print them out. And there's nothing more frustrating than trying to track down an invisible error. Okay, so if we reload the page here, let's see. We got back some data, it looks like. Data, top releases. Sweet. It works. It's alive. Okay, so let's do something with the data. Now, just from your guys' knowledge of React, what's going to happen next now that we got some data in this action handler? Where is data typically stored in a React application? On the state? Sometimes, but mostly you don't. We just store little UI like data on the state in this .state. Oh, we don't do Redux in. Oh yeah, we used to do that as an optional lecture. Okay. The store, yeah, the Redux store. Okay, it just dawned on me. Okay, so you guys, Redux is kind of a big deal.
Yeah, we're kind of just doing it for our project, so.
Yeah,
Go into it.
man, like, oh, well, Redux is a whole lecture on its own, but because I really think it'll make your lives easier, I really think it's worth it for you guys to look at the Udemy Redux course. They have a fantastic course for 15 bucks. That's almost embarrassing that you get 24 hours of lectures for 15 bucks. Yeah, this is the one. I've had friends who have taken this course and had great things to say about it. But they always say this at Udemy, and they're always like, 2 days left, but they just...
Make another deal the next day.
Yeah.
It's just hard-coded.
Days, 2 days.
Random deal between 70 and 80%. Yeah, it's always this amount of money. Check it out. No, 26 hours sounds like a lot, but you can probably see they teach you about how to structure your app. Like there's a lot of really good stuff in here. How to do AJAX requests with React. That's basically where we're at, is we've made our AJAX request and now we need to do something with the data. Okay, so the Redux store, oh yeah, so whenever you have an action, the Redux store is a thing of beauty. It operates on a very simple principle that you have state, and this is not referring to component state. This is like a global application state. When we started out with this state. Top releases was an empty array. UI is like an object that just has search in progress equals false. I was thinking of maybe putting a search bar and doing more stuff, but there's not enough time. Then you have an action that came in. And when the action came in, Redux knows that something's gonna happen on this state. In this particular case, the get top releases request doesn't change anything on the state yet, because this is just the request. We're just letting Redux know that, hey, a request is in progress. We might have changed something if we wanted to like add maybe a message here that says loading data now. In that case, we might change something on the state with this request, but for now, no. And then we get a next state. Anytime an action happens, you have an opportunity to change the state. And the thing that changes the state for you is called the reducer, which is where the name Redux comes from. Redux has these reducers operating on the state. Okay, so let's open up the reducer for every root element in the state, like top releases and UI, has a reducer. So if we look at my reducers, I like to put the reducer for a particular component in the same folder as the component. So top releases has its reducer here. Okay, so this is a function, top releases reducer. It has this switch statement, which is kind of like a case statement in Ruby. So it's saying if you get an action that says get top releases request, return an empty array, because it means we're just fetching the top releases now. Empty, like we don't have any releases yet, but just so we don't return null or something that's going to break the component, I'm just returning an empty array. Then we're saying if you get top releases success, this action, then look on that action's payload, grab the top releases, and return those as the top releases on the state. So once we issue a top releases success, the next state should contain the releases in here. It's like a crazy crash course in Redux. There's a reason they have 26 hours on this stuff, but that's kind of the big picture. Okay, so now I need to dispatch an action, which in the way because I'm using Redux Saga with this tool, I just say put. Oh, actually, I need to rewrite things a little bit for Redux Saga. Okay, let's take this out a little bit. So query, I'm just going to assign our query to a variable. So now, we're just calling client.query to send the query. The tool I'm using, I have to use the call feature to call the request. Call. So I'm going to call the call function, pass the function that needs to be called, pass any parameters that it needs. And we're not going to use a promise. call this, and then the return value of that are going to be our results. And let's just console log the results for now. I hope I got that right. Okay. And nope, not getting those results. Oh, damn it. Redux Saga, I forgot how to use it. Sorry, I'm just going to Google how that. Call context function name. Function as a string. Oh, I need to use a yield. Yeah. Okay. Cool. So now we're getting our data back. That's the results. Okay. And we're going to now we're going to issue the action, actions.get top releases success. Okay, and as part of this success action, we're going to pass in results.data as the top releases. Okay. Oops, I'm missing a bracket somewhere. Yeah, extra round bracket here. Okay, so now we're seeing this get top releases success action being dispatched. We have the previous state where top releases was empty, and we have the new state where top releases is, well, that doesn't look right, but close enough. Top releases got an array. Now it's an array of 5 releases, so we're able to place that on the state. Okay, I need to fix that because top releases should be the top releases. Let's try this now. So, oh. Yeah, there we go. Top releases is just an array of 5 items now. Cool. So I got my data on the state. Now I have to let the UI do something with the data. Notice, though, that it's not showing the loading spinner anymore. That's because my component already detected that we have some data, and I just need to display it. Okay, so going in the component, it got the top releases here. Let's just go ahead and display them. A little Redux kind of tip. This maps state to props. That's saying state.topreleases. This is what's providing the top releases as a property on this component. So when we say state.topreleases, we're referring to this value here that we see on the state and just passing that to the component. Okay, so then I can say top releases is just going to be an array. I can just map over it, and for every single release, okay, for every single release, let's print out the release title. Cool. So we reload. Yay! We got some titles. Oh, we got a warning. Each child should have a unique key prop. That's because every li, when you're repeating something in React, you need to add a key prop. I think map by default adds an index as the second parameter, which is going to go 0, 1, 2 over the index of the array. So So that should do it. So I realized that the actual implementation of this was a little bit confusing, but let me show you guys one more thing. Let's say we wanted the images, right? Like you're coding away, you want the images. All we need to do at this point is go back to the place where we're making the request. And we can say images. And for every image, add ID and URI. So now if everything went well, I should just be able to display the image here. So release is going to have images, square bracket 0 is going to be the first image, dot URI is going to be the URI. And let's go for gold here. Oh, nope. Oh yeah, missing a round bracket there. Woohoo, now we got images. So that is it. That is GraphQL.
That's it, that's all.
That's it, that's all. Done, done. What do you guys think? About this whole GraphQL business?
I think it would be pretty useful in final projects, but it also just significantly raised the learning curve of that project.
Yeah, I'm just going to repeat that for Calgary. So the comment was, sorry, what's your name? Chibwe. Chibwe's comment was, it would be fun to use GraphQL for the finals, but it also really adds to the learning curve. And yeah, I really think that's true. Sometimes it's better to stick to what you know and just make that work.
Yeah.
Because otherwise you run the risk of like completely going off track. And I think
wasting time on, not wasting, like it's really good in the sense that you're learning, but it's like
You don't
that
have
time,
as much time.
you sort of need to create some sort of finished, polished thing, right? And the faster you get there, then
yeah, you need it to work. Like you can't panic. So I totally agree. I don't know if GraphQL is a good idea for your finals. However, Redux, oh man, like I cannot imagine writing a React app without Redux. I strongly encourage you guys, if you have a little bit of bandwidth, maybe on your team, one of you can learn it and then teach the other ones and just be in charge of doing the Redux parts. Because that's really helpful. Unless your app is tiny, unless you have a really small app.
That's what I was going to
Is
ask.
Redux more for like just about like store things up and anything that's helpful?
a lot of state management, right?
Yeah, state management. So
You don't have a lot of things that you just cleans it up a bit, right?
yeah, like if you're building a to-do list app, then okay, you probably don't need Redux. But if you're building anything a little bit bigger than that, I guess what you'd have to do if you don't use Redux is your root level app component, and I should know this because I wrote the Chatty app. Your root level app component has to have all the state. Like in Chatty, it's all the messages that are coming back and forth.
Yeah.
And then that root level component needs to send that data to every single, like down to all the children. Ooh, ouch. Like if you are going even 3 levels deep, that's going to be a lot of typing. But it's doable. It's doable. Yeah, and I guess anytime you make a change, you have to call a function in the root level app component to modify to call this.setState, right, and modify the state for you. And then that re-renders all the children. Yeah, okay, that's doable. Actually, maybe it's not so bad. Yeah. Anyway, still, for the future, if you guys end up working with React, Redux is like pretty much a standard. There's another tool called MobX that some people use. That's all like a replacement. Does the same thing as Redux, but Redux is by far the most popular one, I would say. So yeah, check it out. And Udemy, guys. Udemy is such a great resource.
Yeah.
Yeah, so many good courses. Udemy, and there's Pluralsight. Pluralsight is for more advanced like stuff, and it's expensive. It's $40 a month, but these are my two favorite resources for learning new technologies. Cool. All right. Well, it's almost 11.
Yeah.
Thanks for sticking it out, guys. I know you have 100 other things you need to do right now. Yeah, it was nice to meet you guys. I'll send the lecture notes soon. Yeah.
Thank you very much.
Cheers.